So if you've been watching the channel for a long time, 5-6 years ago, you'll know that I was building a gasifier. There's videos on the channel about the gasifier, how it works, and basically looking for ways to produce power, electricity, off-grid in the event of a power outage. And that's where the whole FEMA gasifier, it's parked over here in the background, that's where that came from. There's some videos on the channel of that. And around that time, prior to that, I had bought 4 of these interstate 6-volt deep cycle batteries, and I was going to do a battery backup with inverters. You can see 2 are missing now, but they're 6-volt batteries that I series wired, these 2, and I series wired the other 2 that were here into 12-volt banks, and then I was going to parallel those 2 12-volt banks into one gigantic battery, basically 12-volt battery. And this is as far as I ever got with it. They sat here for about the last 12 years, is when I bought these batteries, and I didn't do anything with them, and they just kind of went to pot. And it's unfortunate because I spent a small fortune on these batteries back then when I didn't have it, and they just kind of went to hell sitting here. So recently, with the purchase of the Jackery solar generator and a little 100-watt solar panel to charge it, I kind of re-sparked my interest in this, and I wanted to continue on with this project. Obviously, these batteries are no good, but I wanted to continue on with this idea and project, so I started again. Today I took the 2 that were here and I used them as core charges to go turn in, and bought a new pair. So we'll go take a look at that. And here are those new batteries. They are Bi-Mart brand batteries. I picked up this cheap little US General cart to put them on. It's capacity-wise, it'll be more than enough to handle the 4 batteries and the other miscellaneous things that I plan on putting on this cart. But if we go down here and take a look at them, they are Bi-Mart brand 27 RV Deep Sea, which are RV and Marine Deep Cycle, 27 stud. You can see they've got post and stud on the tops of the batteries. Little cheapy cart. I think it was about 120 bucks. And the plan is, obviously this isn't going to be portable, but the plan is to make it movable. So this is going to be like a little roll around, off-grid kind of power station. In the event we lose power for an extended time, that I can roll over to the back of my house, use solar panels to charge it, and during the day, obviously, and keep like my refrigerator and maybe my freezer running so I don't lose any food, right? This will not be like a whole house off-grid kind of deal. It'll just be like an absolute emergency backup to keep essentials running. All right, so today I'm starting to put together my little power cart here. You can see I've got a Renogy 2000-watt inverter. It has 3 15-amp circuits, and then it has a 20-amp circuit that you hardwire. Power cables for it. They are twin 4-gauge for both the positive and the negative, and there's a remote, although I won't be using it. It's about 18-20 foot of remote if you're going to mount this in like an RV or something and you want to remotely turn it on and off. We've got the Renogy 10-amp Wanderer charge controller. This is a PWM charge controller. We've got some more 4-gauge and some terminals and some heat shrink tube. 200-amp DC breaker. I have one on the zip, but it's an 80-amp. Then we've got a gray-colored faceplate and gray Leviton duplex receptacle. This is a 20-amp, and this, along with the faceplate and a box, which hasn't showed up, will get hardwired into the 20-amp circuit on this inverter. So I wanted something gray just so it stands out and it looks different. You look at that and you think, okay, something's different about this, and that is the one circuit that will be 20-amp. So big loads, refrigerators, freezers, that kind of stuff will get plugged in here, maybe a coffee pot, and then smaller loads, lamps and things like that will go into these 3. And then there is a 1014 ohm resistor. So today's progress, we've got the MDO mounted to the cart on both sides. We'll flip it around and look at the other side. We've got the Renogy 2000-watt inverter attached to it. We've got our 200 amp inline DC circuit breaker attached to that. We've got our twin 4-gauge coming in from the batteries, although it's not terminated at the batteries yet, to the circuit breaker. And then on the output side of the circuit breaker, I had to build these twin 4-gauge wires from it to the 12-volt input. The ground wire is very simple. It's attached and it just runs underneath this gap here. I didn't want to run the positive under that gap for fear that, you know, over time maybe it wears through the insulation of the wire and grounds out or something. I'd much rather have it through this MDO that's not going to ground to anything. So I haven't powered this up yet. I haven't charged the capacitor bank that's inside of it or any of that. I got that all mounted. You can see I've still got the duplex receptacle sitting up here and the faceplate. I'm waiting for the box. The box will get screwed right here. Duplex receptacle and faceplate, and then there'll be some SO cord that comes out of the top and right into this here. So that'll be my 20 amp circuit with 2 plugs right there. So this side's pretty much done. Nothing's connected on the batteries yet. I've just got the 2 power cables for the inverter sitting here. I still have to make my twin jumpers, twin 4-gauge jumpers for those 2 batteries. And as I add batteries, we'll add more jumpers. You can see these alligator clips over here. This is just temporary. Those will have an inline fuse, a circuit breaker, one of the 2, I haven't made up my mind, and ring terminals, and they'll be permanently attached to the battery bank. These are the incoming wires from my charge controller, which mounts to the outside over here. So here's my charge controller. You can see again I've got the MDO screwed in here. 6 screws hold it on each side. Punched a hole through here for the connection to go through. This is my solar power input, and it's going to stay outside here. Eventually, I'll probably go to an MPPT, you know, 30 or 40 amp charge controller eventually, as I get better batteries, as I get more solar panels and things like that. But this is just a bare minimum to get me started. So anyhow, this guy's set up here. What I'll probably do, I'm going to put a little, I think Stanley brand trickle charger, so that when the batteries are topped off, I can just plug it in and it'll trickle charge the batteries as they sit here unused. So that'll get mounted over here somewhere. Because this particular charge controller has a 12-volt output here, I'll probably make some sort of little hanger and purchase some sort of 12-volt light. I don't know, probably an LED is my guess, on a cord that I can coil up and hang here, and you can actually turn this output on by pushing the enter, you know, on or off. So I'll make like a little onboard flashlight, corded flashlight or something like that. So what I've done here is I have terminated my negative and my positive to 1 battery inside. I have soldered wires onto each side of that 1,000, it's a 100 watt 1,000 ohm resistor with little alligator clips at each end to make it easy enough to connect. So if we take, you can see I've got my multimeter on the ground, I've got the black wire on the negative of my battery post. If we touch it down here, we've got 0 volts. If we touch it to this side, we've got 12.63 volts. That's battery voltage. So I've got power coming in from the batteries, but I have opened this breaker. You can see the little levers down. So there's no continuity. Nothing's getting to this yet. So what we're going to do is take that resistor and we're going to clip it onto this side and to this side, and it's going to slowly, through the resistor, let voltage build up in the capacitor bank without just sucking a whole bunch of amperage super fast. So basically we're just restricting how much power that it can take. I just think it's easier on stuff. So I'm going to shove this guy in here, hopefully. There we go. And what should happen if this works the way I think it will, clip this guy on here. Now hopefully when I connect this end up here, we don't see sparks and flame and melt shit. And we'll see it slowly, see the voltage start rising, I hope. So here we go. Let's hope this works like I think it works. There we go. We're up to 1 volt. There's 2 volts. So we're going to double check these wires. Yeah, they're nice and cool. The resistor's nice and cool. So that's awesome. So we are slowly charging the capacitors in that 2,000 watt Renogy. So again, this is a 1000 ohm, 100 watt resistor. I think it was like $4 or $5 on Amazon. So we're halfway there. We're at 6.5 volts. Okay, we're currently at 11.88, 11.89, and it's slowly creeping up. So what I'm going to do is I'm going to pull this off now. There's that side. And this side. 11.88, 87, 86. You can see it's slowly starting to bleed off. So we're going to connect this real quick. And there we go, 12.64. I think battery voltage is 12 point, well, it was 12.67, something like that. 12.64 on the top, 12.64 on the bottom. All right, so we're on. We now have full battery voltage on the inputs of the Renogy 2000 watt inverter. So how about we turn this thing on and see if there's a smoke show. Hey, that's a good sign. All right, so I have swapped my meter over to AC and plugged it into the 15 amp receptacle. And we've got 117, 118 volts AC. Should run something. Let's plug something into it. So I've got this drop cord plugged into it. I've got the multimeter back on DC monitoring the battery volts at 12.4, and we'll just turn on this drop light. So we are running the AC drop light off of DC. Now this is semi-cheating because this is actually an LED bulb, so it only draws like 8 watts. I couldn't find an incandescent bulb. I was trying to get a little more draw on it, but you can see it draws the battery down just a little tiny bit. Again, it's, 8 watts isn't hardly anything. But it works, and I've checked all 3 plugs to make sure that they work. I haven't checked for voltage on this 20 amp output, but I can only assume since these 3 work, that works. So this half of the system is functioning. So I have built and installed twin 4-gauge jumpers for my positive and negative. Everything's tight here. I've got my wires for the 2000 watt Renogy inverter also installed, but I haven't closed the breaker on the other side, so it's basically these go nowhere because the breaker's not closed. I've got my charge controller wires coming into the alligator clips, just temporarily clipped on. Again, those will be ring terminaled and bolted. And I've got my probes here, positive and negative, for my multimeter. So when I first hooked this up, I had 12.7 volts on the batteries. I've got my 100 watt solar panel out here in the last little bit of sun that I'm going to get for the day. The batteries are now currently reading 13.34 volts. And we'll come down and we'll look at this charge controller. We're charging at 2.1 amps. Let's see here. That is battery voltage, 13.5 volts. No amps. This would be if we had something coming out of this additional port here. It would tell you the amperage draw. 15 is that setting to turn that on and off with the enter button. So we're getting 13.8 volts coming in from the PV or the photovoltaic cells or the solar panel at 1.9, 1.8 volt or amps. So it's just barely charging at the very end of the sun for my area. But it's just a function test. Everything's working. As it is, charging at 2 amps or what have you, it would take a long time to top these batteries off. But that solar panel out there, it's a Thunderbolt solar panel. It's a folding suitcase or briefcase style. And again, I think it can pump out around 18 volts in perfect sun at around 7 amps maximum. So, it is what it is. It's not bad, but test-wise, everything's working like I was hoping. Yeah, 1.1 amps. And we are slowly losing sun. But, proof of concept, everything's working at the moment. We'll get this set up, and when we have some good bright sun, and I've got a lot more of it, and we'll see what we can get out of that panel. But it's working. So behind the rear wheel of the car, you can see I've got the solar panel out there. This is great sun right now. It's not quite peak, but it's very close to peak sun. And I've got my cord stretched out, laying on the ground here, and it runs up to the charge controller. And we'll take a look at the charge controller. So currently it's saying 14.2 volts coming in from the solar panel and 4 amps. We're charging at 4 amps from the solar panel. The battery voltage is 14.3. When I started, I checked with my multimeter and we were getting 12.73. No amps on the load, and 15 again is the load setting on-off, which we're not using right now. So again, 14.2 volts coming in from the solar panel at 4 amps charge. So that's not bad for one single 100-watt panel. And again, this is a PWM, super cheap charge controller. But anyhow, yeah, a little better results. So we are charging batteries. All right, we've got the solar panel out. It's in really good sun right now. We'll come over here and follow the cable. And as you can see, we're getting 14.8 volts in from the solar panel. We're charging the batteries at 3.8 amps. And the battery voltage is 14.5 volts. So, what I've done here, got my Keurig set up here. And we've got the Renogy 2000 watt inverter on. Same thing, I went and charged the capacitors just like before with my resistor, only now I have my 20 amp circuit in and done, and I've got the Keurig plugged into that. So this is the very first test, actual big test of this 2000 watt inverter. Now believe it or not, these Keurigs are a major draw. They're like 14 to 1500 watts. So I just filled the water. I brought this in from my house. It's completely cold. It was unplugged from the wall. So this is a totally cold run. We're going to see if we can make a hot cup of water. I don't have any coffee cups in it, but let's give it a try. We're going to turn this thing on. I hear it pumping. And we can see the water. Now, I guess you can't see it now. So it is heating right now. As you can see, the little red lights on. And I can hear it heating. And that's a big draw. That's like a 14 to 1500 watt draw on this Renogy. So far, so good. It's handling it just fine. So the fans have kicked on. Let me come over here. I got to shut off my Milwaukee fan. Hopefully you can hear that. They're very quiet. But I can feel the airflow blowing out the top. So those fans suck in the bottom and blow out the top. But it's not loud at all. We are heating water. Still heating, no issues. So while that's heating, we'll come over here and look at battery voltage. We are battery 12.2 volts right there. So it's dropped that battery down quite a bit. Like I said, these coffee pots are big draw. Come on, focus, baby. There we go. Still heating up. I don't know if you can hear it or not. All right, look at that. We got blue lights and our heating element went off. So we're going to open this guy up. We're going to close it. Nothing inside. Let's just do the biggest cup we can. All right, here we go. You can see it pulling water down. And there we go. Got a nice steaming cup of off-grid water here. I'm still going. Everything's looking good. Hopefully it's going to not overrun my cup. There we go. Cool. Pretty awesome. So there's a steaming cup of hot water off grid. It worked. I'll be danged. Well, that's a pretty good test of that inverter. Battery wise, let's take a look here. 12.7, 12.8 coming in from the solar panel. 4.9 amps we're charging at now. It's ramped that amperage up because the battery's gone lower. And the battery voltage is 13 volts. So it used some power, but it did it. Off-grid coffee. Pretty freaking cool. And 2000 watt didn't seem to even break a sweat. So sweet. Well, we didn't hardly wait to make the upgrades. As you can see, we've got a brand new Renogy 40 amp MPPT charge controller. I pulled the old 10 amp PWM off and upgraded to this. We also installed a BT1. This is a Bluetooth module, also by Renogy, that plugs right into the charge controller. That's also compatible with the 10 amp little PWM that was on here. But there's a Renogy app you can download to your phone, and then you can Bluetooth all the information about what's going on charge-wise in real time to your phone. So anyhow, that thing I think has about a 65-foot range or something, so I can see what's going on from inside my house. Because this is a 40 amp charger, we had to upsize our positive and negatives to the batteries, and it's on a 50 amp DC inline breaker. One other thing that I did, the 10 amp PWM also had the same feature, but from the additional output port here, our auxiliary port, you can turn it on or off using this button here, exactly the same as the old charge controller. And that gives you, I want to say it's a 10 amp 12 volt DC output. So what I did here is, you can see this little LED light. I ordered, that's actually a fishing light. Normally they're green. You can get them in white, green, red, I think blue. But I wanted a little LED 12 volt light on a cord. So it'd be basically like a little onboard tethered flashlight, if you will. Now what's really neat is, I don't know if you can do this with a 10 amp charge controller, but you can with this 40 amp Rover. Through the Bluetooth app, I can turn this on or off remotely. So I can turn that light on or off remotely in the house. Let's say I'm using it as a little porch light and I want to come out and look at it in the dark. I can turn that thing on 65 feet away, which is kind of cool. I designed and 3D printed this little bracket for it, and as well as both of the little cord wraps, like what you'd have on a vacuum cleaner to wrap the cord up. You just pull this guy out and it lifts up and comes right off. And then you can unwrap it or unravel it or whatever. But that's the little little bracket I designed and 3D printed. It just clips right into it. Kind of handy. So we'll get this thing fired up and I'll show you the features. It's basically the same as the 10 amp, just has some more features is all. And also, as you can see, we now have the other two batteries. So we got 4 brand new 100 amp hour batteries. They're all wired in parallel, meaning positive to positive to positive, negative to negative to negative. So it's just one gigantic 12 volt bank, basically. Each one of those batteries is 100 amp hours, so should have 400 amp hours. Here you can see where our 8-gauge cable comes in from the charge controller. Positive over here, negative over there. And right here is a temperature probe. And this actually came with that Renogy 40 amp MPPT charge controller. So it monitors the ambient temperature, or the temperature of the battery. I've got it sitting on top of the battery, taped to it. So it knows ambient temperature. So we'll go ahead and fire this guy up real quick. I'll close this breaker. So there, we're powering up. You can see the little green LED on the Bluetooth module on the right. When you link up to it with your phone, that'll flash blue. So right now, our batteries are sitting at 12.8 volts. You can see the little moon shape, and there's nothing moving across this arrow, meaning PVs, as far as it knows, are solar panels. It's nighttime. That's what it thinks. So if we push this right-hand button, you'll see this arrow light up. You'll see this light bulb light up, and that will turn on our light bulb. So let's get it all in one frame here, and I'll show you. You'll push the button now, and holy crap, that thing's bright. Anyhow, we'll turn it back off. Yeah, so pretty darn cool. We'll just go through some of these real quick. So 0.3, that would be our voltage coming in from the solar panels. That would be our amperage coming in from the solar panels. Batteries at 84%. Battery voltage at 12.8. This would be the amperage of your draw. Let me turn that on and see real quick. There we go. So the light's on, and we're drawing 0.4142 amps. So not even a half an amp. Turn that back off. And this is amp hours coming in from the solar panel. Amp hours going out through the light. 22 degrees Celsius. For some reason, you cannot change that to Fahrenheit. But in the app, it reads in Fahrenheit, so that's kind of different. But that's telling us the ambient temperature from that temperature probe. 15 is the setting, telling basically this button turn on and off the auxiliary port. And then if there were any error codes, they would be displayed here, but there's none, so it's 0. And then back to where we were. So I'll swap over, we'll do a little screen record, and I'll show you the app, the Bluetooth setup. Alright, so I've got this Oster hot plate going here, and I'm boiling some water, and it just started boiling here just a second ago. I've got my multimeter set on AC and plugged into an additional port. You can see we're sitting right at 120 volts AC. So even under and this is rated for a 900 watt draw, and it's on high. And at a 900 watt draw, the 2000 amp inverter is still maintaining 120 volts AC. The fans just kicked on. It took about 5 minutes or so to get that boil going. And again, we're plugged into the 20 amp circuit over here. But it's doing great. Still maintaining that boil. It's looking fantastic. When I started, the battery was sitting at 12.9 volts. We're sitting at 12.2 under load right now, so we'll just go take a look here. 53% battery. Of course, that's under load. When we shut this down, that voltage will probably go back up. It's 12.5 right now. I just heard the hot plate kick off. And there it kicked back on. We'll probably see that voltage go down. Yep, there it goes. So that's pretty decent. Maintaining a decent boil. Pretty cool. So I just took the hot plate off, and I've got the hot plate sitting down here on the floor cooling. You can see we're at 12.7 volts, so the batteries have already recovered some when they're not under load. So yeah, that's doing pretty well. I've still got the inverter on, still got my multimeter plugged into it, and you can see we're at 117.5 volts AC or so. Temperature-wise, this thing ran for probably about 5 or 6 minutes until the hot plate started actually boiling the water before the fans ever kicked on. Again, that hot plate's a 900 watt draw in high, and I ran it on about medium high for most of the time until the last minute or so. I cranked it all the way up, but that was not hardly working, that inverter, at all. So I'm having a whole bunch of fun with this setup. I really am experimenting, seeing what all it can do. I plan on getting probably 2 to 3 more solar panels and experimenting with parallel wiring and series wiring them to see what sort of amperage we can get out of that MPPT charge controller. So thank you for watching. If you haven't subscribed to the channel, please subscribe, rate, and comment, and we'll see you on the next one.